All right. Good afternoon, everyone. Welcome to session B344, Storage Management and Virtual Machine Manager. My name is Hector Linares. I'm a program manager with the Virtual Machine Manager team. I primarily focus on storage automation and storage management through standards-based protocols. And so today we're going to be covering all the new storage management features in Virtual Machine Manager. So a few things to highlight as before we start. The demos will be PowerShell heavy, so hopefully you've got some familiarity with PowerShell. I'll try to explain the scenario and what I'm trying to do. It just makes it a little bit easier to demo some of these. So hopefully PowerShell won't be an issue. I will be covering STAN, iSCSI, SAS, Fiber Channel, NAS devices, Windows scale-out file servers. So there's a lot of device types that we manage. So I'll be kind of touching on each one of those. One of the new features around in VMM R2 is the ability to zone in fiber channel switches. So I've got an in-depth demo there as well. And so hopefully that's not going to, hopefully you'll have enough familiarity with that. And finally, bare metal provisioning. Primarily the feature that's already in VMM to bare metal provision Hyper-V servers. We're using that technology now for scale-out file servers. Okay, so the three pillars that we use to focus on storage management really start with insight, flexibility, and automation. From an insight perspective, we're using all of the providers that are out there to actually be able to touch these devices, get information out of them, and then put them really in the context of virtual machine management. So Virtual Machine Manager by itself is, in the more recent versions, is not just about Hyper-V and virtual machines. It's about the underlying fabric, compute, storage, and networking that need to come together to give you a great virtualization experience. So we want the insight into all the storage devices that are out there and then really put them in the context of VM, because that's really how you're managing these environments, is storage and how it's associated to the virtual machines. We then use those capabilities on Insight to then put some what we call classifications, give you the ability to say gold, silver, bronze storage, and really this is what gets surfaced up to self-service users. So the self-service user experience is not about picking a server, picking a LUN, and all of the details that go into deploying a VM. From a self-service perspective, what you want to offer to your end user is the ability to deploy applications into capacity. So that you want to have a gold cloud, a silver cloud, a bronze cloud, then you can also classify your storage and assign it to those clouds in that way. So you can have premium storage, mid-range storage, and low-cost storage associated to those clouds, and then charge customers accordingly based on if it's a chargeback model. So we do all of this using standards. SMIS is one of our primary investments when it comes to storage management. So we take all of that information, then we build one layer up and talk about flexibility. We want to make sure that we're not just managing one type of device or one protocol. We want to make sure we manage everything that's in the data center. So we go from the high-end devices, Fiber Channel, iSCSI, all the way on now to the Windows scale-out file servers, which are built on commodity storage, JBOD enclosures, SAS disks, SAS connectivity. So we have the full range of devices in between. And what's new in R2 is now the ability to do zoning. So Fiber Channel switches now is another device is managed by VMM. So we work with the industry to make sure that devices are supported, devices are tested, providers are tested. We make sure that the providers scale. So we want to ensure that whatever we manage, we can manage it at scale for the enterprise. So we take insight, flexibility in devices, and we build automation. And I'm not talking about regular PowerShell commandlets that you have to automate yourself. We're talking about end-to-end workflows in Virtual Machine Manager. The ability to rapidly provision virtual machines using a SAN snapshot or a SAN clone. The ability to provision a new scale-out file server and provision storage and provision the file shares without having to go to 4 or 5 different consoles. So we want to streamline the workflows, build turnkey solutions, and really get away from the business of the individual nuts and bolts of how to do these things and focus more on the value add of what you're trying to do with virtual machines. So those are the main three areas, and you'll see as I walk through the presentation how each one lines up from an insight perspective, device perspective, or automation. So I'm not going to go through every one of the features that that were delivered in 2012 RTM. Just want to highlight that there's a lot out there from a storage perspective. So the landscape that VMM sees is actually growing with every release. So this is 2012. There was an incredible bunch of features that were introduced, and so many so that we actually couldn't keep up with the rate of change. So if you've been using VMM, you'll notice that we didn't have support for ODX. We didn't have support for virtual HBAs. There's a laundry list of features that we just couldn't get to simply from a timing perspective. So that's one of the areas that we focused on going into R2, is to make sure that we can continue lining up with all the features and enable end-to-end scenarios. So this is the 2012 wave of features and capabilities. And again, there's a lot that was delivered by both sides from a Windows Server perspective on the platform and System Center management. So when we set out to build the features in R2, there's a few things that came to mind when it comes to enterprise storage management. Now I'm going to focus here on fiber channel arrays, iSCSI arrays, from partners like NetApp, EMC, Dell, Hitachi, etc. There's a lot of work that went into the 2012 RTM and SP1 feature stack, and one of the things that was missing was better enumeration. So we did a lot of work to optimize the services that we use to ensure that we can scale to the larger 30,000, 40,000 LUN devices that were taking a long time to discover and manage. We've started to optimize that and do a better job of that. We've also started to integrate with better SIM indications, or in other words, eventing. So we want to make sure that anything that happens outside of our view of the world, let's say an administrator uses another admin console, creates 20 LUNs, using indications, instead of having to refresh the entire array and get all the information out, we actually get indications and events that tell us 20 new LUNs were created, you should update your database. Right, so we've done that work so we can scale as the devices scale. When we started looking at how we were going to manage virtual HBAs or synthetic fiber channel in Hyper-V, there's a few things we were looking at on how do we automate that end to end. And one of the gaps that we figured out is that we have to manage fiber channel switches. So we do this in the zoning in the context of virtual machines. We've extended it to Hyper-V servers as well, but really the key value add here is how you can deploy virtual HBA with zoning through VMM. And the last piece is on rapid provisioning. And this is something that comes up on every release cycle. When we're asking for requirements, make it so that VMs deploy faster. And if you're familiar with bits, you'll know that today VMM takes a long time to transfer 8, 10, 20 gigs over the network. So we've done a lot of work there to improve not only integration with ODX, but difference in disk as well. So let's cover one scenario, and we'll build it up in the context of VDI, virtual desktops. Okay, so at least the customers, when we work with customers on VDI, they're looking for on-demand provisioning of virtual machines as customers roll into their environment or start up their day. They want the ability to scale with minimal impact to the network, minimal impact to their capacity. In other words, they want to be very efficient. So how can VMM meet some of those requirements when it comes to rapidly provisioning VMs and being efficient? So there's several capabilities now in in VMM. SAN copy is the first one I'll talk about because it's already a feature in Virtual Machine Manager. It essentially allows you to do a snapshot or a clone of a LUN with a VHD. Okay? And then you clone the LUN or snapshot the LUN, unmask it to a host, and then you use the VHD that's on that LUN to provision a VM. So now you're in the 1 VM per LUN scenario. So obviously we have customers using today, so it's acceptable in some cases, it's not acceptable in other cases, especially if the arrays can't handle hundreds or thousands of LUNs being provisioned. So we set out and said, okay, we need to do two things. Definitely we need to integrate with ODX, and we need to integrate with ODX because now that gives you rapid provisioning from a template, from a library, into a CSV or into an SMB3 file share, which is kind of like the holy grail when it comes to provisioning at scale. So if you're familiar with bits, you know that you'll have a read of a file from the library. It transfers over the network, over HTTP, HTTPS to the Hyper-V server, and then it gets written down to disk. Right? So you definitely have the spike on both sides from a network perspective, CPU load as well, and especially if you're using a secure channel. Now, if you, one of the improvements that we've done in R2 is to use copy file 2 APIs that are native in Windows. So in the same way that you would copy a file on your desktop from one location to another, we're using those same APIs. So even if you don't have ODX, you'll immediately get some improvements as far as file copying. Now, if there is ODX, then basically what happens is nothing actually gets transferred over the network from a data perspective. Tokens get passed back and forth. Basically, a token is read from the array. The token represents a set of blocks. It gets written on the destination, and then when the token gets written, it essentially knows that it should copy over a file, or copy over a chunk of a file. And that happens multiple times, and then you get your file to wherever location you want. Now, that can be a CSV, that can be an SMB file, SMB3 file share. So that's the ODX feature that we introduced in R2. And difference in this support, what we've done here is we've actually automated not only the provision of the VM with a diff disk, but also the caching of the base VHD. Okay, so instead of having to manually copy over a base VHD, put it into a location wherever you would want to put it, and then creating the VM with the diff, we actually do that end to end now. So I'll show you that in a demo. Okay, so let's kick off this first demo. So this first demo, what it's, I'll set it up here. First, actually, okay. So in this first demo, what I'm doing is I'll kick off a bits deployment, a traditional. I'll kick off a traditional bits deployment. Essentially, like I was mentioned before, we end up consuming a CPU and networking on both the source and the destination, so the library and the Hyper-V host. And so, it's thinking. That's not the transfer. That's actually something else. So. Give it a few minutes to kick off. So what this demo is trying to do is actually, so it's going to first copy the file using bits. And so you'll see a CPU spike and networking spike on both the library and the Hyper-V host. There we go. Weird behavior, sorry. So, CPU load, network load, both the library server and a Hyper-V box. So what we want to do instead of having to copy this file, and this is a 7 gig file, in about 30 seconds I'll probably copy 7% of the file, 7 to 10%. So what I'll do after that, I'll cancel the job and say, you know what, let me switch over to ODX. And so what we're using in the background here is a NetApp array, and that same copy, so the same template, same VHD, same library server, same Hyper-V host. Now I'm going to switch over to ODX, and what you'll see is that neither the library or the Hyper-V host are impacted from a network perspective. And not only that, what you're going to see here, let me switch over here. So as this VM is getting deployed, I will show you the subtask that's actually doing this right now. So we're essentially transferring at a much higher rate than you would ever get with bits. Again, this is the value of ODX and offloading all the data transfer to the array. So in about the same time that I would have transferred 10% of the file, I'm pretty much going to be done with the VHD deployment. And then once we finish the VHD, we're then going to start customization. So in about the same time, you get a fully configured VM in a powered on state. Yep, so you'll get a fully configured VM in a powered on state running through customization. And you can now do this at scale because now multiple VMs can be deployed, leveraging all the capabilities of the underlying array without having to consume any network on the any storage, any capacity on the network. Now, depending on how the array implemented ODX, if the array is very efficient at creating copies of data, or in other words, creating pointers to blocks of data, then you're going to get a very efficient copy of the VHD from a SAN perspective. Because there we go, let me show you this, so, or not. So you'll get a very efficient copy of the VHD from the SAN perspective because it doesn't actually have to copy the blocks over and over in order to create a copy of that VM. So I'm not sure what's happening here with the network, but I will. Let me switch back to the presentation. I'll keep going for now, and then I will come back and look at the diff disk demo. So there's going to be two demos there: ODX demo and then diff disk deployments. So let me see. Maybe I'll just finish it up here. All right. So the VHD completed the transfer. The VM is now powering on, and it's now going through customization. So I'm going to close this part of the demo. Let me flip over to diff disk. So there's two sides to the diff disk deployment. The first one is actually going to show you that we will actually copy the base disk that's being used for n number of VMs to a special location. And that location is actually specified at the host level, and that's where you would store all parent VHDs. That could be an SSD drive, that could be on a CSV, could be on an SMB file share. So that initial copy, so we'll transfer the file over, and in this case, I'm transferring over a simple 1 gig file. Obviously, I don't want to sit here longer than that, but basically, this is the task that's happening here, which is the 1 gig file getting transferred over. And so we'll store the parent VHD in a special location, whatever one you designate. And then the VM, which is the folder on the right where it says VMs, that's where the VM is actually going to get created, and the config file, the diff disk, and everything else. So we populated the cache with the diff base, and then we're going to start customizing the VM. So in this case, this is a blank VHD, so there's no file, there's no OS to customize. So I'm going to stop with that one. And so now I'm going to repeat the same deployment. Again, same template, same everything. The difference is that now, since we already have the base cached, we don't have to wait through the transfer of the file. And you'll actually get a much faster deployment of the VM because we're just leveraging what's already on the host. So in this case, now the VM is pretty much complete from a deployment perspective. We didn't have to copy any files, and we're able to spin up the VM and get it starting on customization much faster than we could ever do this in previous releases. Okay, so those are our diff disk and ODX investments for rapid provisioning. Switch over to a slightly different scenario around Tier 1 applications. Tier 1 applications that require some sort of high-end fiber channel storage from an array. Now, in typical situation, you want to deploy a SQL server. You might want to deploy it on fiber channel storage. If you want to deploy that SQL server in a virtual machine, you still want to have access to that fiber channel storage. Obviously, that's why you would need virtual HBAs. So the virtual HBA case, now what you really want to do is create a guest cluster. Essentially have multiple VMs set up as a failover cluster connected to one or more LUNs. Okay? So what we've done in VMM, and this is obviously new in R2, is that we've introduced support first for fiber channel switch management. So that includes discovery of the switches, ports, zones, zone sets, fabrics, everything that is important for managing a fiber channel environment using SMIS. And we've also introduced zone set activation. For those that aren't familiar with the terminology, switches use zone sets as a database to distribute how the zones are actually configured. So when you activate a zone set, which is a collection of zones, it's actually distributing the database to all the switches, and then all the zones get activated that are part of the zone set. And so we do the same thing for zoning as well. So we create zones, we delete zones, we add members to zones, etc. So that's the first part. laying down the foundation to ensure that we can actually manage the switches. So we've also done the work on the Hyper-V side to create what are called virtual SANs. Virtual SANs essentially are a collection of physical fiber channel ports that you're going to use to connect one or more virtual HBAs. Think of it as a vSwitch, not completely analogous, but basically you connect a virtual NIC to a vSwitch, and a vSwitch has some number of ports. In the fiber channel case, you have a fiber channel HBA connected to a virtual SAN, and the virtual SAN has one or more ports. Now, Hyper-V is the one actually doing all of the NPIV management, vPort creation, vPort deletion. So VMM is now out of that business. We had a feature in previous releases where we would actually do vPort creation deletion as part of SAN migration. We've done away with that. We've deprecated that feature, and now we're shifting over to letting Hyper-V actually manage that. So we got the Hyper-V virtual SAN management. The final piece from a VMM perspective is having the ability to create a VM template with virtual HBAs. And once you have the virtual HBAs in your template, create one or more instances of that VM configured with a virtual HBA and connected to the right vSAN. Right? So we've done that work from a placement perspective and also from a template perspective to make sure that you can get a template with virtual HBAs deployed and fully configured on a Hyper-V host. And the last piece around guest clustering. So now VMM can unmask fiber channel LUNs directly into the virtual machine, and we've automated that process as well in our UI and CLI. So now from VMM you can go from switch discovery, VM creation, zone activation, LUN creation, LUN unmasking, and get those presented into your virtual machines. So let me show you that demo. Oh, sorry. So just to recap on the differences of how you would do this if it was in a physical world. If you were doing a physical deployment with servers and into an environment for SQL, the actual deployment of a physical server probably takes days, weeks to months, depending on when you can actually get it racked and configured. The connectivity, in other words, the zoning and all the work that has to be done, could take days or weeks. There's some companies that only do zoning on the weekends, for example, updates to the zone sets, just because of it's either a fear of changes during the week during production, which makes complete sense, but it requires that you wait until that time. And then provisioning of the LUNs could take ideally minutes, hours, sometimes days, depending on how the SAN administrators are dealing with other issues in the environment, and so you'd have to wait for them to do the configuration. So if we switch over and say, okay, what if we did the same thing in virtual machines? If you can model the virtual machine as a template and deploy it, you can do that in minutes. Get it deployed, get it configured, no problem. You still have the connectivity problem from a zoning perspective. You still have to wait those days and weeks to potentially get all the zone set activated. Provisioning perspective, if the array is managed under VMM, you can do that within minutes, get that storage completely configured. So what we've done in VMM is that we handle the modeling, we handle the virtual deployment of VMs, we handle the connectivity, so we can do all the zoning. We also do all the provisioning of the LUNs and unmasking. And from a Hyper-V perspective, if it's from a live migration, you get live migration support for VMs configured with virtual HBAs. If the VM is in a Hyper-V cluster, you also get the availability from a failover perspective to ensure that the VM or the set of VMs are always available. So switch over here. So I'm going to spin up a different demo. Let me set the stage here. Okay. So I'm going to walk through a PowerShell script to get us configured. The first thing I'm going to want to do is actually do the modeling and the deployment of the template. Okay. So the first thing I'll do, I already have a template that I've created. This template has 2 virtual HBAs, and I'm going to get a handle to that virtual HBA to that template. I'm going to use that in a service template. One of the reasons why you would want to do this in a service template, for those that are familiar with service templates, they're essentially a set of connected VMs that might house an application like SharePoint or some other application like that. You'll have a web tier, a line of business layer, and a database. From a database perspective, you might want to have those VMs running SQL connected to shared storage. in this case, fiber channel storage. So that's the reason why I'm doing this in the context of a service template, and then I'll show you how that shows up in the UI. So I got my template. I'm going to call new SU service template, and I'm going to pass in that template into the commandlet, and then I'm going to add a tier to the template. Again, remember, line of business, web, line of business, SQL. So I'm going to add the SQL tier to this template. I configured a VNIC. Sorry, I hit twice too fast. Enter fast. I configured a VNIC. I just told it what I'm going to connect to. And now I'm going to create a new service configuration. Service configuration is used to configure the settings for the deployment. So I start with a template. I go into a configuration. The configuration is my deployment document that I'm going to use to pass into placement, and then actually go and deploy that configuration of the VM. So I get the VM configure. I get a configuration for the VM, and now we're talking about the VMs that are part of the service template. And in this service template, I ask for 2 VMs in my data tier. So I'm going to configure the first VM. So for the first VM, I'm going to set a location of where I want the virtual machine to be deployed. I do that for the second VM as well. And this is where you start connecting the VM, the deployment config, to the virtual SAN. So what I'm basically telling the configuration here is that for my first virtual HBA, I want to connect it to my storage classification called Cisco vSAN2. Right? Classification is just a friendly name for the array, for the fabric, where I want to connect this virtual machine to. So I basically have to do that for every virtual HBA. So I'll do it 4 times because I've got 2 VMs, 2 HBAs each. And I'm going to now configure. Now, obviously, the storage for the data hasn't been configured yet. So I do need to tell VMM where to place the OS VHD. OS VHD is not going to be on the storage LUN. Right? The OS VHD is still going to be a separate VHD that resides maybe on a CSV, on a file share, etc. So I configure where I'm going to put the VHD for the base OS. I do an update SC configuration, which essentially runs it through the placement engine and then finds all the applicable hosts where this VM can be deployed. And to show you the level of information that we get from a placement perspective, I'm going to run get VM host ratings for all the hosts in my environment. And what I'm showing you here are all the reasons why a host can or cannot host a VM. Host these VMs. So in this particular environment, for demo purposes, I've got a small environment. Only one of the hosts is actually applicable, which is the first one, the one that ends in N08. No deployment errors. Every other host either doesn't have the fiber channel or doesn't have any network connectivity that I specified. Right? So that's the level of detail that you can get from a placement perspective. But we do the work of finding the right host. I mean, I'm going through the process step by step. From a UI perspective, you would be able to just run through placement, get everything configured, and then hit deploy. Okay, so I'm going to finish this part. So assume that what I was going to show you next is a VM has now been, a service template has now been deployed. I've got a service instance now as well, and I would have essentially 2 VMs for my data tier. See if there's maybe another network connection here. Hold on a second. Okay. So I'll switch over to the VMs and services workspace. And in this case, I've got 2 service templates already deployed. So I'm going to work from the bottom up. And so the data tier at the bottom essentially has 2 virtual machines in the data tier. One of them is powered off. And the first piece I want to show you is that if I go into the properties for this VM and I click on the storage tab, so this is a new tab for a VM level, what you'll see is here that I could potentially add a fiber channel array. So this is what I would typically call onboarding the array to the VM. So I'm connecting this VM to the fiber channel array. To do that, I need to create a zone. In this case, I can't do it. One of the reasons is because it's not connected to the right fabric. And so if I click over to another VM, you'll see that the fiber channel array option is enabled. The reason why it's enabled here, not in the other one, is because since we know the fiber channel switches, we know all of the arrays, we know how everything is connected, we won't just show you a list of arrays and have you figure it out. We'll show you the right array in the context of that virtual machine. So if the physical machine is connected to a Brocade switch, but the array is connected to a Cisco switch, they're not common fabrics. So we're not going to just show you a list and have it fail. So we'll guide you in the right way to ensure that you can add or onboard the array correctly. So in this case, I've got a 3-PAR array connected to my Brocade fabric. And what I would do here to connect the VM to the array is essentially create the zone. And so I would name my zone. I would pick the array that is visible on that fabric. And then I can pick the ports on the array, so the target ports on the array side. There could be many. There could be up to 16, 32. So you pick the ports that you want to get zoned, and then you pick the virtual HBAs that you want to be part of that zone on the VM side. So I'm going to cancel this. I won't actually go through this because I already have one already prepared. So if I would have gone through that zoning process and activated the zone set, what you would see, and I'm going to go back to storage, is that now the array has been onboarded. Now that I have an array that's onboarded to this VM, now I want to provision storage. So provisioning storage per VM in a service tier doesn't make sense because you actually want to expose it to all VMs in the service tier. So now I'm going to click on the data tier, and there's another storage tab here. And in this case, now I can add a disk. So here I've already got a LUN created on the 3-PAR array, and I'm going to hit OK. Now I'm going to switch over to the VM that's actually hosting this. So this is the virtual machine that has the virtual HBAs. It's got 2. And essentially I zoned it to 2 ports on the array. So without MPIO, you'd see 4 disks, right? 4 paths, 4 disks. With MPIO enabled, and once you've claimed the devices, what you would see here is 1 disk. So let me just make sure that the job completed. Oops. Yeah. So the registration task is the one that unmasks the LUN to all the VMs. All right, so that's completed. I'm going to go into the VM and rescan disks. And so now in Disk Manager, what you're going to see is the LUN that just appeared. Now, I'm not showing you every VM, but essentially on every VM in that data tier, that LUN has now appeared. You can now initialize it, partition, format it, add it to your cluster, and then put your application on top of that. All right. And just to show you, so we've done this for VMs. And one of the requests that we got a lot from customers is, can you do this for a host? We do this for iSCSI arrays today. So on the Hyper-V host, if I click on storage, I can have an iSCSI array already provisioned. In this case, you can also add a fiber channel array. This particular host, again, is not on the fabric. Actually, it doesn't even have HBAs, so it wouldn't make sense to expose it to that host. N08, which is the host where I'm running all my virtual machines, if I go into the properties for that host, storage, I would be able to add the fiber channel array. Now, I haven't done that just to show that it's not required that the host be zoned to the array in order for the VMs to get access to the array. Those can be zoned completely independent of each other. Okay, so that's the fiber channel demo. Switch back and continue. And just, I want to highlight the fact that we've been working with partners for quite some time now to get this going. So Cisco and Brocade are both supported through SMIS, and actually I've been getting a lot of those questions at the booths this week. And so they both got providers, and we've been working with both of them for the fiber channel switch management. So how do we do this? How do we get all of this done? One of the core pieces of technology that we leverage in Windows Server is called SMAPI, or Storage Management API. This is the central API that VMM uses for all storage management. There's a few things that here and there that we might have to peek out and maybe do something a little differently from a legacy API perspective, but pretty much all the calls that we make are done through this API. And so that includes iSCSI configuration, MPIO configuration, all the SAN provisioning, NAS support as well is done through this, and also fiber channel switches. Now I want to highlight the fact that we use something called SIM pass-through in order to get us access directly to the providers for capabilities that are not in SMAPI. New zone is not a commandlet you'll find in Windows Server. New zone, you'll find it in VMM, but we're using pass-through to get down to the provider. And so, when you map out all of the different devices that VMM can handle, it's a growing list. And now with fiber channel switches, that list will continue. NAS devices as well, scale-out file servers, all of that is managed by VMM. There's different types of providers, whether they're embedded or proxy, and if you're using the integration today, you'll have different partners have a different approach to how they want their storage managed through SMIS. So we leverage a concept called classification very heavily, both on storage provisioning and also now for fabric management. So if you're familiar with classification in VMM, in existing products of VMM, you can today classify a storage pool as gold, silver, or bronze. Now that's great if you actually have SMIS integration. What customers have been asking for is, they've been telling us, well, what happens when you don't have SMIS integration? What if you don't have a provider? How can I still classify my volumes without having to unclassify the pool? So in R2 now we've introduced the ability to classify volumes, right? So if you have, let's say, a host with an SSD and some local SAS, you can now put your SSD as gold storage and your SAS as silver, for example. And then when you do a VM deployment, you can land VHDs specifically where you want to land them based on placement and incorporating into classification. We've done the same thing now also for file shares. So file shares is a new feature it's a capability that we've had in VMM. We've continued to invest in that, and one of the features now is the ability to classify a file share individual from separately from the pool. So you could, for example, have a silver pool of all SAS disks, as an example. And then you go into the file share and call it gold because maybe you've enabled deduplication, so you want that to be the most space-efficient storage. So you can actually classify them separately depending on what your requirements are. So we give you that range of flexibility. You don't have to do this. For example, if you just do the pool and say gold, everything on top of it is gold. But if you want the flexibility to say, I want to treat this share differently because it's encrypted and call it a different classification, you can do that. And we've also ensured that all of these classifications bubble up into the VM cloud. So if you're using VM clouds today, you actually cannot guarantee that a VM will land on gold storage. That's just a gap that we had in SP1. R2, we've completely fixed that. We've ensured that placement handles all of the classification in a cloud. So if you want to deploy a VM to gold storage, which could be represent a file share, that's now fully handled in VMM. We've also extended the concept of fabric classification to give fabrics a friendly name. So you can call different fabrics by either an SLA or a performance guarantee that you have, gold, silver, bronze as well. And again, placement will ensure that it finds the right host with the right connectivity on the right fabric to get you what you need. This is the SP1 list of supported partners. This list will grow as we go into R2 and as partners continue to validate. And so this is available both in the MMS presentations and these presentations as well, whether it's NA or the European TechEds. And so as always, if there's partners that you want to see work with us, just let us know, and we can definitely reach out to them. So far I've covered VMM's management of fiber channel switches, SAN devices. I've only covered fiber channel really. There's also iSCSI support. There's also SAS support. So really we're just talking about block management. Now there's the devices underneath, the middle layer here, from a switch perspective, from a connectivity perspective. The only switch today that we manage are fiber channel switches. If you've attended the networking talks for VMM, you know that we do have better switch port management from management at a port perspective for the top of rack switch. So we haven't fully integrated that yet into the storage side of the house, but we've started with fiber channel switches from an end-to-end provisioning perspective. So iSCSI Target is one of the features in Windows Server 2012 RTM that's now in-box. And in the previous release, we shipped a provider, an SMIS provider, that VMM put in its setup directory that you would have to install manually, onto the iSCSI target. In R2, now that provider is part of the platform. So the minute that you enable iSCSI role in Windows Server R2, the provider is automatically enabled. And so there's no need to install a separate package to get that going. So let me quickly show you that integration in VMM. So if I switch over to the Fabric view and then go to classification and pools, I've already got an iSCSI target imported into VMM. Now the way that this looks on my cluster is I've got both roles actually deployed on the same failover cluster. So in the later demo, I'll show you the scale-out file server part of this. But this is the same cluster. So you can have one cluster with multiple protocols, iSCSI and SMB3. And now VMM can manage that same server with both those protocols. Sorry, could you repeat that question?
Why would you still maintain the iSCSI when you're working on SMB?
There's always going to be a requirement around having iSCSI storage. So we want to make sure that we're inclusive as far as management. So we already managed iSCSI in the previous release. So we're just continuing that management.
Meaning the space is part of it is relevant to the iSCSI?
Yeah. Sorry for the mic. So the first question was, why do we continue managing iSCSI if we have SMB3 and scale-out file servers? And again, the answer is because of just including all the different protocols, all the different devices. Now, can I deploy scale-out file server storage using spaces? So for the second question, I'll switch over to the disks view in the cluster. So you can't use CSV with iSCSI target. It still has to be an available disk. But once I have an available disk, assign a drive letter like I, for example, that disk is coming from from spaces. So you can use common JBOD storage for both SMB3 and for iSCSI. So you get commodity storage with different protocols on top. Okay, so let me switch over back here. All right. So now we're getting into the iSCSI space. We're just filling up the stack. Again, from an Ethernet perspective, we don't manage switches in the context of storage, right? Over time, we can work on that, but today that's nothing that that layer for us is opaque. We don't know what's in there. We can't see inside of that. We don't do any configuration from a switch perspective. So as we start pivoting now from the enterprise over to service providers that want to offer the best capabilities at the most cost-effective storage, you start seeing a big shift in Microsoft in our direction as far as what do we support from a storage perspective. Now you've probably seen multiple presentations over this week that talk about scale-out file servers decoupled from Hyper-V clusters. So you can scale Hyper-V independent of your underlying storage. Now, that storage using a scale-out file server presenting SMB3 shares obviously could be, the back end of that could be a fiber channel iSCSI array. The other option is to use spaces. So one of the features that VMM did not have support for in SP1 is actually discovery and configuration of spaces. And so now we've fully integrated that stack into the scale-out file server. So the way that ends up looking from an infrastructure perspective, if you're building large-scale environments for private cloud and you want to have cost-effective storage that's optimized on capacity, optimized on performance, then you've got a pretty good stack when it comes to Windows Server 2012 R2 and VMM 2012 R2. Because now you can create tiers with spaces. You can add right back cache. You can then also dedupe the volumes once you have files on there deployed on there. And you can do all of that within the platform. So if I work from the bottom up, the provisioning of spaces requires a few things. First, I have to be able to discover the fact that there are physical disks attached to the physical machines that are providing the scale-out file server cluster. So that discovery of physical spindles then allows us to create pools out of those spindles. So you add spindles to pools. From pools, I can create a space. From a space, I can add that to the cluster, have it initialized, partitioned, formatted, and then I can land my scale-out file server share. So from an end-to-end management perspective, just having that alone is very powerful because we can automate the entire workflow and also have it ACLed to a Hyper-V cluster. And if you have a 64-node cluster, you probably don't want to ACL or add the computer account for every machine in the cluster. We've gone a step further in this release, and now we support bare metal provisioning of a scale-out file server. So starting from zero, with no operating system on the physical machine, we can actually build up each one of the nodes in a scale-out file server cluster, enable the roles for failover cluster, enable file server, do all of that work, and then get a fully configured scale-out file server cluster. Then we can do the spaces management, then we can do the file share management. All of that through VMM. So what VMM has introduced in this release, like I said, from a Hyper-V cluster management perspective, we already support bare metal provisioning. We've extended that now to scale-out file servers. We've extended the capabilities for storage provision now for new pool creation on spaces. And from a share perspective, in SP1, we would basically create a share on an existing volume. We've gone ahead and now done the entire workflow from an intent-based management perspective. You give us a name, a size, and a pool, and we do the rest of the work. So let me show you that integration. So in the Fabric view, I have something called file servers. So this is an existing Scala file server that I've deployed. But if I wanted to start fresh, if I have a set of brand new machines connected to JBODs, and I wanted to go in and create a cluster out of them, just like you would create a VM out of a template, we need a template to create to use for physical machines. So what we've done here in this release, we've changed VM host profile to physical computer profile. We've made it generic, and now we support multiple roles. So if I were to create this profile, you essentially give it a name, and you tell VMM what type of profile this is. It can either be Hyper-V, a Hyper-V cluster, or Hyper-V node, i.e. a VM host, or it could be a Windows file server. So if I pick a Windows file server, hit next, I still have to pick the OS that I want to deploy on it. So I'll pick something from my library. This is a VHD that's already stored in the library. And I'll hit next. Now I can do all the configuration for the server. So if my server has multiple NICs, I can assign DHCP, I can assign static IP. If I want to configure my base disk, the physical disk that will hold the OS in a very special way, I could do that as well. So you use a template, you use a profile as a way of telling VMM, this is how the server should look. This is the intent. All right, this is what I want it to look like. You can also include drivers if you want to add more as part of the deployment. And then I go through and also customize the operating system. Product key, domain, join, everything else. All of that gets captured into the profile. So once I have a profile created, now I want to go and actually create the cluster. So I'll go to Fabric. On the top of the ribbon, I'll hit Create. And from Create, I will click on File Server Cluster. So the File Server Cluster wizard, it's a few pages. It's going to ask you a few questions. But what we've essentially done here is a turnkey solution for scale-out file server deployments. And so all you would have to give this interface is a name for the cluster, since we're creating a brand new cluster, and a name for the file server. Remember, the file server is a role that gets enabled inside a failover cluster. And that requires its own IP address because it's a different entity on the network. So I hit next. Now I have two options for bare metal provisioning. For provisioning file servers. I can either pick a set of existing servers with an operating system. They don't have to have failover cluster enabled. They don't have to have file server enabled. We'll do all that work. But if you already provisioned a server, you can use those. The more interesting one is if you want to do bare metal provisioning. So in this case, for bare metal provisioning, I actually need to go and reach out to the BMC cards or the baseboard management controllers and power on those machines. But once they're powered on, I need to know what OS to deploy and what to configure. So that's where the profile comes in. So I've already selected my profile, and I hit next. So I've got to tell VMM what credentials should it use to communicate with the baseboard management controller, because there's no operating system on the physical machine. So I pick a credential, I pick my the protocol I want to use to communicate with the device, and then you give VMM a range of IPs. So this could be, a range of 10 or 4 or 8 or whatever size of cluster you want to create. Typically, we're recommending around 4 nodes for a scale-out file server cluster. You can have 2 if you want. And then you give VMM that set of IP addresses. VMM will then go off and discover the BMC cards, then start the provisioning process of powering on the machines, letting them PXE boot, downloading WinPE, and downloading the VHD, getting boot from VHD configured, and then we continue that and take over and create the cluster, and finally provision the file share, the file server. So let's assume I've already done that. So now I've got a file server. Not only do we provision a file server, we actually bring it under management. So there's a new provider that's in Windows that actually allows us to do cluster-aware spaces management. So with one provider, we can communicate with the entire cluster and get a cluster view of the storage for that set of servers. So in this case, I already got the Scalable file server deployed. Sorry. In the ribbon, I'm going to click on Manage Pools. So I've already got a pool that I've created, but if you have available disks, you can go off and say New Pool. I can pick a set of disks. I can name this Demo Pool 1. I can classify this pool, so I'll just call it Demo, and I'll hit Create. So I'm going to bring this over to the side so you can see what's happening on the file over cluster. So let me switch over here to pools. So I've got one clustered pool today, which is cluster pool 1. So when I hit OK here, we're going to go off and talk to the unified the cluster-aware provider. We're going to get all the disks. We're going to create a pool, and then we're going to make sure that it's part of the cluster. Okay. So once the clustered pool is available, I want to go into the same file server cluster and create a file share. So again, from the ribbon under Create, I'll do a Create file share. Let me switch over here to the disks. So like I said before, I'll give it a name. Again, now we're creating the file share. Give the file server name, a file share name. I want to create a file share from a pool. I pick the pool that I just created, which is Demo Pool 1. I can either leave the classification as is or pick a new one if I want to. And then I can give it a size. And I'll hit Create on this one. So what's happening here is we'll actually do multiple steps. The first step we'll do is go off, get the pool, create a space. Once the space is created, it gets attached to the cluster. Once it's attached to the cluster, we then need to initialize, partition, format it, and once it's available at that level, we can add it as a CSV. We add it to the cluster, and we make it a CSV or a cluster shared volume. So that's the disk that you just saw pop up there, and if I switch over back to the roles, again, I had the iSCSI one here before, and now I'm going to switch over to Scalable file server. This is the file that I just created. So within a few clicks, I kind of went through that fast, but we essentially went from no OS on the physical machine all the way up to a fully configured clustered scale-out file server. Provision of pools, provision of file share. So what's left? Now I can go to my Hyper-V cluster, so my VMM demo clue. Go to Properties, File Share Storage, Add, and now I can select that file share and then have it ACLed into VMM. Right, so I selected the file share, and what I'm telling VMM is, for this file share, add all of the computer accounts that need to access this file share. Now, in addition to that, add the management account that VMM uses for any other operation, for like VM creation and other operations that are not managed by Hyper-V. So that brings me from bare metal all the way up to a share that I can use for VM deployment. Okay? Any questions on that? Because that's definitely a lot of area that was covered. It requires a lot of knowledge of all the different, all of the different layers of not only what VMM offers, but also Windows Server. Yes?
You mentioned the cluster-aware provider. Is that only in R2 or will that be available in 2012?
So the question is, I mentioned about the cluster-aware spaces provider, and if it's going to be only available in R2. So the answer is yes. It's an R2 feature only. Okay? So the last piece of this is now that we've built up this cost-effective storage stack all the way to file shares. What happens if I want to create a guest cluster using VMs on that type of storage? So, quick reminder of what we went through from a fiber channel perspective. We did a lot of work to make this really happen end to end. Okay, all the switch, the zoning and the vSAN configuration, the VHBA information, and then unmasking the LUNs. It was a significant amount of work to get that all end to end. But we want to make sure that this is a seamless experience. Well, what if you want to do the same thing for VMs but on the file share? So, as you probably already know, Windows Server introduced shared VHDX, the ability to share a single file across multiple VMs. And for that, they've introduced SAS controllers, a virtual SAS controller in the VMs. These SAS controllers support persistent reservations, and that's how you can actually get guest clustering support in a VM with a shared disk that lives on a file share. It can also live on CSV. But the point here is that now you have the same experience from the same ability to create a guest cluster on tier 1 storage. You can also do this now for commodity storage. So let me quickly show you that integration. So if I switch over back to the VMM view, I'm going to go to library. Let me close this. So I'll switch over to VM templates now. So I want to show you that I've got a shared VHDX template. This is a normal VM template. When I open it up, if I go to hardware configuration, under hardware configuration, I'm going to find the VHD file that's on my SCSI controller. And in this case, I haven't set it to be shared, but I can if I want to. But this is the option that would essentially cause this VHD to be shared across multiple VMs. But this is just a template, so I want to leave it generic. Let me switch over now to the service template view. And now I'm going to create a service template from the ribbon. So I'll click on the service template action. I'll do a simple 2-tier service template. Hopefully it doesn't disconnect again. No. So wait, so if you're, how many of you are familiar with the service designer in VMM? Have you used it before? Okay. So when this finishes, I'll give you a quick tour of that. So the question is, what's a typical example for guest clustering? The typical application will be SQL. So a highly available instance of SQL. You can do file servers as well. In virtual machines, you could definitely do that. Yeah, so the question is, do you keep the OS disk separate from the data disk? The answer is yes. So the OS disk can't be shared in this model, shared VHDX. Each VM has their own independent OS disk and then a common disk that they both access. And that's how you get shared storage. Yep.
Storage classification of tiers with gold, silver. If you have as a MIS provider, you can ask for storage. The iSCSI target as a MIS provider, how does that work there, or doesn't it? Am I missing something?
I'm not sure what the question is.
How do we ask Windows iSCSI target that has it as a MIS provider, what tier it is, what level of what tier their storage is, gold, silver?
So okay. The question is how. Yeah. So the question's around how do we get classification from an iSCSI target? The thing is that classification isn't discovered. Classification is set by the user. So you have the power to say, this is my gold storage, this is my silver storage, this is my bronze storage. However you want to classify that. Today we don't actually pull capabilities and form classifications from capabilities. Say again? For all of them. So for any array, for any array that we manage. No. The SMIS spec doesn't actually have something like that where we can auto-discover classification. Okay, so this finally came up. So what I have here is a 2-tier template, and I've essentially got to drop a template into one of these tiers. So I'm looking at my shared VHDX template again. I'm going to drag and drop that into the service tier. And so now this is going to be my data tier. This is going to have potentially multiple VMs that will act as a set of connected VMs for a cluster. And if I double click in here, I go to hardware configuration. I've got access to that VHD file. And now here I can say specifically, I want this template, this computer template, the machine tier template for this data tier. I want that VHD to be shared across all of the VMs in that service tier. So I pick that setting. And the most important part is from a scale-up perspective. I can first specify how many VMs automatically get provisioned when the service template is used to deploy a service instance. So in this case, I can specify I want 2 automatically created. And I want to have a maximum instance count of 5. That means it can scale up to 5 VMs. So by just clicking on that checkbox that says share this VHD or this disk with all the VMs in a tier, we will automate the attaching of that VHD to any new VM that gets created. So you don't have to go and manually figure it out and say, where is it missing, where is it not missing. As you scale out, you'll get the VHD automatically added. Now, from a scale-up perspective, you're going to have some script that automatically does something on the application side if it needs to. If the application can just say, here's a new disk and use it, even better. But if you have to add it to the cluster first or do something special inside of the application, you would still need a script to handle that, but that can be done as well through VMM. So that's the shared VHDX and guest cluster integration. Put the shared VHDX on a? Well, so let me, yeah, so, say again?
So you can differentiate it on a performance?
Yes. So the questions are around the shared VHDX and where would you place it. So you have full flexibility to place it on a file share or on a CSV. And the OS disk and the shared VHDX don't have to live together in the same directory. So you can have a Scalable file server that has no dedupe enabled. So a good example of this is, let's say you have a SQL workload that's going to be using that VHD. Good chance that it doesn't dedupe well. So you probably don't want to enable dedupe for that VHD. So you will have one share that's maybe gold but no dedupe, right? So you can land the shared VHDX on a file share that doesn't have dedupe. But the OS disk, good chance they'll dedupe well. You want to have that on a file share that dedupes well, and you have that full flexibility. Will we use it for logs? That's up to the configuration you want. So you can create separate disks for each one. Yeah, that's fully configurable. Yeah, actually, Kurt here, he's a PM on the VMM team. He's got a service template, I think, with like 15 VHDs, right? So you get full range of customization you can have there. Okay. So to finish up the stack, we talked about fiber channel SAN, fiber channel switches, SAN, iSCSI, SAN SAS. Now, the last piece of this is all the file-based storage. So I haven't shown any of the NAS integration because there's nothing new that we've done there, but we do support NetApp and EMC for their SMB3 implementations using SMIS as an interface. And like I mentioned before, now we've got the end-to-end stack when it comes to spaces and scale-out file servers. We don't do anything special for isolated target. Look, in other words, we won't create an isolated target role. We won't automate the same way we did for scale-out file server, but you can definitely configure that and have it managed by VMM. So in summary, some of the main drivers of what we do from an automation perspective really deal around 4 customer pain points. The first one is spending a lot of time getting storage provisioned, waiting for storage to be provisioned. We want to make sure that we can bring that down to 0, if possible. And one example of that is the work we've done with virtual HBA. We want to make sure that that is as seamless and as frictionless as possible. So we help you automate all of that through VMM. There's some customers that simply don't have the expertise to do all of this work outside of the context of a management tool. If they had to go to every one of the devices to stitch together a virtual HBA deployment, it's probably sometimes beyond the reach of some customers. So we want to make sure that we handle that as well. There's some customers that are sophisticated, but they simply have too many devices in the environment. And so if you create automation for one thing, you might do one operation across many devices. Or you pick one device and automate end-to-end, but then you don't have the consistency across devices. So by using standards-based management, we can eliminate that complexity from an API perspective, still give you all of the value out of the underlying devices, and add all of the standardization when it comes to automation. And for those customers that have done this, really the example is around human error. That's what I hear over and over. If I've automated, I've done this to eliminate human error. So we want to take that to the next level and continue driving standardization and consistent workflows to minimize and eliminate that human error part. Partners as well are definitely seeing the advantages of what we're doing here as far as end-to-end management and automated workflows and more turnkey solutions. And so you've got partners coming up to us and talking to us about taking VMM information out of the product and then putting it into their consoles. Right? So in other words, VMM has the context of virtual machines, storage in the context of virtual machines. Take that same data, flip it on its head, and say, here's my storage in the context of VMs, or here's my fiber channel switches in the context of VMs. Here's my array in the context of the VMs. So if you get a support call on either side, you'll be able to say, okay, everybody has a common language that says this VM name, and everybody knows what that means. And they can see it from both sides of from a management perspective. And also from an API level, PowerShell is obviously something really important. And so we see a lot of partners asking us, what do we build? What do we continue building? And so what happens now with SMAPI is that you get PowerShell out of the box. You plug in the provider underneath, and then the command list just light up. Right? So then you can eliminate that frustration of which APIs to build, and you can start standardizing on a set of PowerShell interfaces. And the perspectives that we get from different customers as far as embracing the cloud design points that customers are doing today, this lines up with the investments that we have in VMM and in Windows Server. From a partner perspective, partners get the full ability to highlight all of the value out of their devices, but in very turnkey style solutions built with VMM and also with System Center. And for service providers, if anybody here is a service provider or a hoster, if you have that that private cloud vision or the hosted cloud vision, there's a lot in the Microsoft stack that's getting built up that actually will help you eliminate all that overhead of management, and where you can focus on the value add services on top. So to recap some of the history of where we've been, VMM 2007 all the way to 2008 R2 SP1 really had 3 levels of management, either NPIV, vPort creation deletion for SAN migration. We integrated with VDS hardware providers for masking and unmasking. We did some iSCSI initiator log on log off. All of this was in the context of a VM that I've provisioned manually. Let me migrate it using SAN. In 2012, we kept that same capability. We switched over to a new service that we created internally that was SMIS capable, and then we started adding capabilities. So we focused heavily on onboarding iSCSI arrays, the ability to create LUNs, whether they're thin or thick LUNs, the ability to discover pools, etc. So we took that approach in RTM using standards-based management. We went a level further now with Windows Server 2012, and if you see that blue box, now we switched over to SMAPI. So that alone, basically all it's telling us is VMM did the forklift effort to go from one API stack to another. We kept all of the investments, and then we started to add more. And so we added more capabilities from a block perspective, and then we started adding also file share management. SP1 was the first time we were actually managing NAS devices and scale-out file servers. So if you take those set of investments in 2012 up to 2012 SP1, if you look at R2, we've kept those investments. We've added all of the fiber channel management, and that, like I mentioned before, all the way from the discovery of the physical fiber channel fabrics, all the way up to zoning and adding members for VM guest clusters. We've continued to expand our investments in scale-out file server, and that's all of the spaces provisioning, pool provisioning, etc., and now intent-based management and file share classification. We've gone also the step further to say, let's make sure that we're optimal on deployment, so ODX integration. I didn't show this, but VHD resize is now supported, online VHD resize, and also support for shared VHDX. So that's the stack that we've been building over time. And like I mentioned before, the reasons why we continue investing like iSCSI and Fiber Channel, again, is we want to be inclusive of the entire data center, right? And we want to build a lot of this value add stack across all of the different devices. So there's a lot of sessions that cover storage in a TechEd. Make sure that it's already Wednesday, so Thursday, sorry. Some of those already passed, but they've already been online, so please do check those out. You can reach me at either hectorl@microsoft.com or you can follow me on Twitter. There's some resources for Channel 9 and TechNet that are worth checking out. Please do fill out your surveys. Definitely want to hear your feedback so we can continue improving these sessions, definitely delivering the content that you want to see out of TechEd. Thank you to all the partners in the room, all the partners that will hear this online, for helping get us this far. It's been a huge investment across the board with all the partners that we work with, and it's a lot of work, but I think it's definitely worthwhile. And from all of us on the VMM team, thank you. Thank you to all our customers and all our partners, and I appreciate it and continue enjoying TechEd. Thank you.